Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Wireless troubleshooting is fundamentally different from diagnosing problems on wired networks. Unlike a cable run that stays fixed and predictable, wireless networks are constantly affected by physical surroundings, competing signals, and mobile users. A device that works in one part of the building may drop out in another, and performance that seems fine during setup can degrade suddenly due to interference or load imbalance. The very nature of wireless introduces instability, which is why specialized tools and methodologies are necessary. Solving wireless problems means understanding not just device settings and configurations, but also the environment in which the network operates. In this episode, we'll explore the tools and techniques used to analyze wireless performance. You'll learn how site survey tools, analyzers, spectrum monitors, and access point logs come together to diagnose real-world wireless problems. We'll also look at how to track bandwidth usage, monitor channel saturation, and interpret key performance metrics like signal-to-noise ratio. These diagnostics are essential for both day-to-day network support and certification readiness. Wireless is everywhere, and the ability to troubleshoot it effectively is one of the most valuable skills you can develop as a network technician. Well, let's begin by outlining some of the most common wireless issues. Users often report intermittent disconnections, especially in environments with roaming or overlapping access points. Others experience weak signal strength, particularly at the edge of coverage areas or behind walls. Slow speeds and complete loss of connectivity are also frequent complaints, and they may stem from interference, authentication problems, or overloaded access points. Unlike wired problems that are often binary, plugged in or not, wireless issues are frequently intermittent and contextual, requiring ongoing monitoring and real-time analysis. Wireless site survey tools are designed to visualize signal strength and coverage throughout a physical space. These tools, available as both software and handheld devices, map SSID availability and report signal levels in different areas. Site surveys help identify areas of weak signal, excessive noise, and overlapping coverage. During planning, they inform access point placement. During troubleshooting, they reveal coverage holes or poorly configured APs. Heatmaps produced by these tools are especially useful for diagnosing dead zones and areas where devices routinely disconnect or roam too aggressively. Spectrum analyzers take this a step further by scanning all radio activity in the environment, not just Wi-Fi. They detect non-Wi-Fi interference, such as signals from microwaves, Bluetooth devices, baby monitors, cordless phones, and even fluorescent lighting ballasts. These devices operate in the same unlicensed frequencies and can degrade wireless performance without being visible to standard Wi-Fi analyzers. Spectrum analyzers display noise levels and signal spikes across frequencies, allowing you to pinpoint external sources of interference that may not appear in Wi-Fi-only diagnostics. Wi-Fi analyzer applications are another key diagnostic tool. These run on laptops or mobile devices and show available SSIDs, signal strength, channel usage, and encryption type. Some tools include graphical comparisons of networks on the same channels, highlighting areas of congestion and overlap. These apps are especially helpful in urban areas where multiple wireless networks compete for space. By analyzing channel distribution and signal quality, you can decide whether to reassign channels, lower transmit power, or change frequency bands to reduce contention and improve performance. Bandwidth usage monitoring provides insight into how much data is flowing through each access point and which clients are consuming the most bandwidth. This data is often available through wireless controller dashboards or SMP-based monitoring tools. By tracking bandwidth consumption, you can identify top users, rogue devices, or applications causing congestion. This is especially helpful in guest networks, classrooms, or shared workspaces where a single misbehaving device can impact everyone. In managed environments, bandwidth data also helps enforce usage policies and optimize traffic flow. Understanding channel utilization and saturation is key to diagnosing network congestion. Each Wi-Fi channel has a finite amount of capacity. When too many devices use the same channel, especially in the 2.4 GHz range, performance drops for everyone. High channel utilization leads to retransmissions, latency, and reduced throughput. Wireless controllers and analyzer tools can show you how much of each channel is being used and by whom. Armed with this data, you can shift access points to less crowded channels, adjust transmit power, or reassign SSIDs to different bands to spread the load. Wireless packet capture tools provide deep-level visibility into 802.11 traffic. These tools allow technicians to capture real wireless frames, including management, control, and data frames, for detailed analysis. Packet captures are useful for diagnosing handshake failures, authentication timeouts, and frame retransmission issues. Capturing wireless traffic requires a network interface card that supports monitor mode, which allows it to listen to raw frames on the air. While not always required for basic troubleshooting, packet capture is invaluable when users experience authentication loops or when devices fail to join the network altogether. Wireless controllers and AP dashboards provide a wealth of diagnostic data. You can often review client association history, including which access point a device connected to, signal strength over time, and frequency band usage. Controllers log retry rates, error counts, and authentication failures. This data is crucial for identifying devices with weak signals, frequent reauthentication, or compatibility problem. It also helps spot hardware faults or configuration mismatches. Reviewing client logs from the controller gives a much broader and longer-term view than simply observing the problem in real time. Finally, wireless logs and alerts play a critical role in diagnostics. These logs include disconnection reasons, such as signal loss, roaming failure, or excessive retries, and authentication problems like timeout or invalid credentials. DHCP failures often appear in wireless logs when a device connects successfully, but fails to receive an IP address. Wireless systems can also alert you to rogue access points, unauthorized SSIDs, or excessive channel interference. These alerts can be configured to notify admins when performance thresholds are crossed, helping you take proactive steps before users experience problems. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. A critical metric in wireless performance troubleshooting is the signal-to-noise ratio, or SNR. This figure compares the strength of the Wi-Fi signal to the level of background noise on the same frequency. A strong SNR means the signal is much louder than the noise, resulting in clear communication. A low SNR, on the other hand, means the signal is being drowned out, often causing dropped packets, retries, and low throughput. Typical SNR thresholds for reliable performance fall in the 20 to 25 dB range or higher. If your signal is strong but SNR is still low, you may be facing interference from nearby electronics or too many access points operating on overlapping channels. Band steering is a feature on many modern wireless networks that encourages dual-band clients to use the 5 GHz band instead of 2.4 GHz. This reduces congestion and improves throughput, since 5 GHz supports wider channels and less interference. However, not all devices handle band steering gracefully. Some may cling to 2.4 GHz, even when better 5 GHz coverage is available. Others may disconnect or stall during the transition. Troubleshooting this feature involves monitoring client association patterns, verifying that devices are connecting to 5 GHz when expected, and adjusting access point settings or signal thresholds to fine-tune behavior. Legacy devices may require special SSIDs or exclusion policies. Roaming and handoff issues are another common source of frustration in wireless environments. As users move through a building, their devices should seamlessly switch between access points with minimal disruption. When handoff is poorly configured, or when access points lack sufficient overlap, users may experience dropped calls, frozen video streams, or delayed page loads. Heatmaps can help visualize where signal coverage overlaps and whether roaming thresholds need adjustment. Ensuring consistent SSIDs, encryption settings, and authentication policies across all APs is also essential. Fast roaming protocols, like 802.11r, can improve handoff performance when supported by both clients and infrastructure. Client device behavior plays a huge role in wireless troubleshooting. Often a problem isn't with the network itself, but with how a specific device interacts with it. Logging tools can show whether a device is roaming too frequently, failing to renew DHCP leases, or struggling with authentication loops. If the issue follows the user regardless of location or AP, the device itself may need configuration review or a driver update. On the other hand, if the same symptoms appear on multiple devices in one location, the problem is likely environmental or configuration-based. Monitoring reassociation frequency and device signal levels over time helps isolate whether the issue is network-widely or device-specific. Captive portals can also introduce complex troubleshooting challenges. When users connect to guest networks, they are typically redirected to a login or agreement page before full access is granted. When this fails, users may appear connected but be unable to reach any sites. Common causes include DNS resolution failures, where the portal can't redirect the browser, or authentication timeouts, where the user's session expires before completing login. Browser caching can also interfere. Users may be loading a previously cached success page rather than a fresh redirect. Troubleshooting captive portals means clearing browser cache, checking DNS settings, and ensuring the redirect server is reachable and responsive. Wireless printers and Internet of Things devices introduce a different set of challenges. Many of these devices are limited to the 2.4 GHz band and do not support enterprise-grade wireless authentication. Some also lack display interfaces, making it difficult to know what network they are trying to join. Troubleshooting often involves verifying that the correct SSID is available, confirming whether MAC address filtering is blocking the device, and ensuring the device is within range. Assigning a static IP address can reduce DHCP conflicts, especially for printers that must remain reachable by users. When possible, isolate these devices on their own VLAN to reduce broadcast noise and simplify access policies. Wireless troubleshooting questions are common on the Network Plus exam. Expect scenarios where users experience dropped VoIP calls, slow speeds in one area, or failure to authenticate. You may be asked to select the correct tool, such as a spectrum analyzer, site survey app, or controller log to diagnose the problem. Other questions may ask you to interpret SNR values, channel overlap, or identify whether the issue lies in client configuration, network congestion, or physical interference. Recognizing which data source to consult and which tool to deploy will help you navigate these questions with confidence. To summarize, wireless troubleshooting combines environmental awareness, diagnostic tools, and careful observation of both device and network behavior. Site surveys help you understand coverage, while spectrum analyzers detect hidden interference. Logs and dashboards give insight into association failures, retry rates, and client health. Packet captures allow for protocol-level inspection, while SNR and channel analysis guide performance tuning. Effective wireless support requires both visual tools and deeper logs, because what looks like a simple drop in signal strength may actually be a complex interplay of noise, saturation, and device limitations. Wireless troubleshooting is rarely as simple as unplugging and replugging. It requires an understanding of physical layout, radio frequency behavior, and client variability. With the right set of tools and the experience to interpret them, you can isolate root causes quickly and solve problems before they escalate. Whether you're diagnosing a coverage hole in a conference room or figuring out why a device won't join the guest network, your approach should always start with data: signal levels, logs, client history, and spectrum visibility. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.